Welcome to Maths with EJD. I've been making a series of videos on basic calculus, and now I'm making some on integration. This is the third one in that series of integration videos. And here we are considering indefinite and definite integrals. Okay, now let's see what that is about. Indefinite and definite integrals like this. And the integral is the result of integration. So an integral is the result of integration, while an integrand is the result. While an integrand is the function to be integrated. For instance, if you have integral of say 4x squared plus 7 dx. Okay, so when you integrate this, of course, you're going to get something like 4 over 3 x raised to power 3, then plus 7x plus a constant c. So this now is your integral. The result is your integral, whereas the integrand is the function to be integrated. So this 4x squared plus 7 is your integrand. Okay, is your integrand. The result you get is integral, while what you integrated is called integrand. Okay, so the result of an indefinite integral, the result of an indefinite integral is a function with an arbitrary or actual constant, as the case may be. So if you end up having this expression with a c, or you even have extra information like the one we had, let's say y of 0 equals -1, for instance, that can enable you get your c. What that integral is still indefinite. So the only time the result of a definite integral is usually a numerical value. So the only time your integral will be definite is when you integrate between an interval. We are going to see that very soon. Let me not go ahead of myself. Okay, let's see in slide 16 the actual differences between indefinite and definite integrals. So an indefinite integral can be expressed as this: integral of f of x ds equal. So that gives you, so this is the integrand, this is the integral. Of course, this is your arbitrary constant. So you always have your arbitrary constant or even an actual constant, right? Where f of x is the integrand, like we said, and f of x, big F of x, is the integral, and c is an arbitrary constant, like that. So here it is indefinite integral, even if you have extra information to get your c, as far as you end up having something in terms of x. But then when does an integral become definite? A definite integral can be expressed as integral of f of x dx from a to b. So once you have that interval with for differentiation, for integration, then it becomes it becomes a definite integral, because at the end of the day, you're going to end up having a particular value, a number as answer or something, or you are going to have a constant as answer, so to speak. So here now, if you integrate this, normally you should have f of x plus c. But even if you have f of x plus c, by the time you evaluate it from a to b, the c will end up canceling out. So at the end of the day, you have f of x from a to b. That means you evaluate it at b, you have f of b, then minus, you evaluate at a, you have f of a. So f of b minus f of a. So where f of a and f of b are the values of the integral f of x evaluated at the integral limits a and b. So it means that once an integral has limits, then the results you are going to get to be definite. And that means you are going to get a number, a numerical value, a constant as the answer. So the arbitrary constants cancel out in the process of substituting a and b. That's why you don't get to see the c here at the end of the day, right? So that's the difference between definite and indefinite integral. So let's take a very practical example to demonstrate this. Okay, you see this, you want to evaluate integral of x dx. That's one thing. And then you are integrating integral of x dx. You're evaluating the integral of x dx from -1 to 2. So of course, this first one is indefinite, while the second one is definite, because this one has no interval, whereas this one has a specific interval within which you are differentiating. So it's pretty easy. Integral of x dx straight off is, this is x now. That's like x raised to power 1. So to integrate that, increase the power by 1, and then you divide by the new power, which is 1 plus 1. So that's why you have x raised to power 2 divided by 2 plus c. So this is the indefinite integral. Indefinite integral. And then For the other one, you have integral of x dx from -2 to 1. That's what makes it definite. So here now, of course, you integrate the same way. You have x squared over 2 plus c. I put the c here so you can see how it cancels out at the end of the day. So you have that, but now from -2 to 1. So that means 1 is at the top, right? So evaluate this expression at 1. Wherever you see x, put 1. So that means you have 1 squared divided by 2 plus c, let's have it that way, minus, then put -2. So you have -2 squared over 2 plus c. All right. So you have 1 squared is 1. So you have 1 over 2, then plus this normal c you have here, minus, let's still do this, 2 squared, -2 squared is 4. 4 divided by 2 is 2. So you have 2 plus c right there. So now you have half plus c minus 2 minus c. So you see minus c plus c cancels out. So at the end of the day, you have 1 over 2 minus 2. So 1 over 2 minus 2 over 1. So the LCM is 2. 1 in 2 is 2. 2 times 1, 2. Minus 1 in 2, 2. 2 times 2, 4. So you have 2 minus 4. That's minus 2 over 2. Okay, something is wrong there. So 2 in 2 is 1, right? So 1 times 1, 1. Minus 1 in 2 is 2. 2 times 2, 4. So you have minus 3 over 2. And that is why you have this. So that's all about indefinite and definite integrals. So when you're integrating without without an interval, you get an indefinite integral. When you integrate within a specific interval, then what you get is a definite integral. Thanks for listening. Make sure to subscribe so you can get all the videos that will come your way. Thank you.